So hi guys, um, welcome back to my channel. For today's discussion, we have masterclass video 2, and we have two topics to be discussed. So first is area. So under the area we have three topics. It's area under the curve, and area between the curve, and polar areas. So next is volume. So in volume we'll also have three topics or three methods in volumes. It's this method, shell method, and washer method. So I will discuss you these two topics in my masterclass video 2. So today we're gonna discuss about area under the curve. So first things first, you gotta remember that the integration is somehow closely related to the area. So it's like this, guys. So the derivative, so what does your derivative results or give you is the rate of change. Rate of change. And the rate of change geometrically is gives you the gradient. So this means that if your gradient is negative, your rate of change is also negative. So whatever you have in here, it's getting lower, lower, and lower. So integral is not about the rate of change, but in contrast, it's about so the rate of change is the derivative, but the total change is the integral. Total change the integral. So what does this give us is that total change will give us the area. So in here, integral and area are somehow connected, but there is some distinct difference between them. So for the area question, we have a 3-step that you can do sometimes depending on the question. So we have here, so for area you can be sick. So we have here S for sketch, I for identify integrals, C for combine and conclude. So this 3-step area question may generally apply to all area questions, but sometimes it depends if the question is already given sketch, so you don't need to sketch it, but you need to identify the integrals and combine and conclude. And sometimes you don't need to combine, and you just need to conclude depending on the question. So for area question, we have the basic sketch, identify integrals, combine, and include. So we're gonna put this into some problems, so you'll see. So this is our question. Find the area of the region bounded by y equals 3x minus x squared and the x-axis. So we don't have any drawing here provided, so we're gonna follow these 3 steps. First is to sketch. So just sketch, not drawing or make it very beautiful, just good enough to be understood by your teacher or your classmates. So first we're gonna sketch. So first things first, you're gonna ask yourself, what will you sketch? What is it? So here you can see what will you can sketch. So what kind of sketch will we draw? So here we can see we have y 3x minus x squared. So by this we can conclude that what we're gonna sketch is a parabola, and it's upside down. So why is it upside down? So we can see that the coefficient of x squared is negative. So first we're gonna factor this out to make to identify our features easily. So for we're gonna factor this out. So first we're gonna have x here, and that will leave us 2 3 minus x. So from this factor, what are we gonna get? So we can ask yourself, what can we get from this factor? So it's the intercept. So because we get this 2, we can find our intercepts. Here, x, you can find our x intercepts 0, and this one, you can find our x intercepts equals to 3. So now let's follow the area question. Let's sketch now that we have our intercepts. So when you sketch, it's important that it's understandable, not that very beautiful sketch, but just normal sketch. Yx. So now we know that our x is equals to 0 here, and then we have our x here, which is equals to 3 here, and you know that this is a parabola, this upside down, so we're gonna have this something like this. Okay, and this is our y equals to 3x minus x squared. So now that we have this, we're gonna go back to the question. Find the area of the region bounded by y equals to 3x minus x squared and the x-axis. So now that we have our intercepts and our y equals to 3x minus x squared, so this is the area that we're gonna find, this one. Okay, so we already done our sketch part. Now let's go to the second part, identify the integral. So we're gonna identify the area of the region bounded by y equals to 3x minus x squared. So we're finding the area under the curve. So we're gonna have your area equals to the integral. So in here, we're gonna have to figure out what is our limits. So in here we have our x equals to 0 and x equals to 3. So it is what are we gonna put this? Our limits must be put in order, so in order not to mess our area. So we have our limiter 0 to 3. So what are we gonna integrate? So here, this is what are we gonna integrate. So we have here 3x minus x squared, and don't forget your dx. So in somehow you know how to integrate this now. So in here we're gonna have by using the power formula, so we're gonna have your 3x squared over 2. So how did this happen? So by applying the power formula, we're gonna add to this exponent plus 1, and also to the denominator plus 1. So we're gonna have 3x squared over 2. So next, still the same, apply the power formula. We're gonna have x squared here plus 1. We're gonna have cube over 3 and close bracket, and don't forget our limits 0 to 3. So what are we gonna do now here? So we're gonna just apply the substitution without any complications. So we have this open parenthesis. We have first our limit 3 multiplied by 3 raised to 2 squared over 2 minus, here we're gonna substitute that. We have 3 cube over 3 minus our limit 0 to 0, and then we're gonna get 27 over 2 minus 27 over 3. That's how we substitute our limits. So after this, we can factor this out. We'll have we have here what all this 27 open parenthesis, we're gonna have 1/2 from here. We're gonna take our constant out. We have 1/2 minus 1/3 here. So we have here the denominator. We can cross multiply it, and we're gonna have equals to 27 over 6, or we can simplify this as 9 over 2. So what did we do all over? So we already sketched here. We already done our sketching part, and we also identify our integral here, and we already solved this one. And our third step will be combine and conclude. So in this problem or situation, we cannot combine because we only have one integral. So in here, we're just gonna conclude this. So when we conclude, you're gonna think that we're finding the area. So by concluding this, we can put this as the area. The area is 9 over 2, and very important is, don't forget the unit squared. So by concluding like this, it's gonna help you be more familiar with how to find the area, so you won't forget your unit squared because we're finding the area. So this is the best way you can do it. So we already sketch, identify, integral, and conclude. So see you on the next topic. Hello, welcome guys to our next topic. So area between the curves. So we already discussed about area under the curve, so now we're gonna discuss about area between the curves. So let's have here. So let's say you have a sketch here, and we're gonna find a function here, and we have let's call this f of x, and we're gonna find the area under the curve with a to b. So the formula for this is just area equals to integral of a to b f of x dx. And next, let's have here another function here. Let's call this g of x, and we're gonna also find the area under the curve of a to b. And this the area formula for this is just the same. Integral of a to b is just the function is g of x dx. So what if we combine this two functions? So let's have here the f of x, function f of x, and function g of x, and we're gonna find the area between the curves a to b, this area, because in this f of x we're gonna find this under the curve is this area, and here g of x we're gonna find is under the area of g of x. So what if we're gonna find the area between two functions f of x and g of x? So how we can get the area of f of x and g of x here? So we're just gonna find the difference between the area of f of x and g of x, and we're gonna find this area here. So simply area is just equals to integral of a to b f of x minus g of x dx. So what we're gonna do is find the difference of the top function and subtract it with the bottom function, so we can get the integral definite integral of f of x and g of x, and we're gonna get the area between the two curves. So what if we have the y values? So we have here what if we have here f of y, and we're gonna find the area under the curve C to D. So this is also the same to the x values, but this one is just y. So we can so the area for this is just area is equals to integral of C to D f of y dy, because we're finding the values of y, which is simply just x is equals to f of y. So what if we have two curves on y value? So we have here, so what if we have here f of y, and here we have g of y, and we're gonna find the area between this curve from C to D here. So simply the formula for area is also the same as the x values, but we are going to use the y values. So we have here integral of C to D, from C to D, open bracket f to y minus g of y. So this one on the left side is our g of y. This one on the right side is our f of y. So here in our right side we have our f of y minus, so we can find this curve, the area between this curve, minus subtract here to g of y, like this, dy. So you got to remember this. If you're dealing with f of x, so it's simply just y equals to f of x, while if you're dealing with y, it's simply just x equals to f of y. So we already discussed how to get the area between the curves, so now let's apply it to the problem on next video here. So in here we have a problem: find the area of the region bounded with the line y equals to x and y equals to x squared. So first we're gonna sketch here like this, and then we're gonna find the intercept points here. So we can do this by making this both equal. Okay, so we have here x equals to x squared, and we're gonna subtract both of them by x, so we're gonna get 0 equals to x squared minus x, and we're gonna factor this out, so we'll get 0 equals to x, open parenthesis, we have x minus 1 here. And then by using the zero product property, we can get here this one, just like we did on our previous. We can get this x equals to 0, and this one is equals to x equals to 1. So now we can sketch this here. So this line from x equals to 0, this one will be our f of x equals to x, and this one, this line here, also we have our intercept 1 here, and then we're gonna draw our next line, our g of x. So we're gonna have here a line like this, and this one will be our g of x equals to x squared. And in our question, find the area of the region bounded by the line. So we're gonna find this area, this one, this area. So simply our formula from our discussion in here will simply be just this one. So have with this, our area is equals to integral of a to b f of x minus g of x dx. So simply by substituting, we can get this as this one. So area is equals to integral of we now have our limits 0 to 1. So from 0 to 1, x1 minus x squared. This x1 is just f of x, okay, dx. So this is by using the power rule. We have x squared over 2 minus x cubed over 3. And don't forget with the limit of 0 to 1. So by using our substitution, we can substitute this as 1 squared over 2 minus 1 cubed over 3 minus 0. This is just 0 here. Then we're gonna get our answer of 1/2 minus 1/3. So after this, what we're gonna do is we're gonna multiply our common denominator, which is 1/2 multiplied by 3 over 3, and 1/3 minus 1/3 multiplied by 2 over 2. So here it is. We have 1/2 multiplied by 3 over 3 minus 1/3 multiplied by 2 over 2. So simply we have 1/2 multiplied by 3 over 3 is just simply 3 over 6 minus 1/3 multiplied by 2 over 2 is simply just 2 over 6. Or simply we just have our answer as 1 over 6. So that's it for our area between the curve. Hello guys, for our next topic is about polar curve. So first I'm going to teach you how to graph a polar curve. So here first, a circle, okay. So example, if you have r equals to a cosine theta, so what will be the curve here? So this will be a circle, okay. So this will be a circle like this, okay. So basically a is the diameter of a circle, and the center of the circle here, when you go up from here to get this point, is just 1/2 of a. So basically, if your a is equals to positive, if your a is positive, it's gonna be open to the right, okay, to the right. But if your a is negative, your circle will open to the left. Basically from the center to here is your 1/2 a, and the diameter from here is basically your a, okay. So let's try this with an example. So I think we can do it here. So example, we have r is equals to 4 cosine theta, okay. So we're gonna draw here, sketch first. So how do we know this if it's going to the left or to the right? So our A4 is positive, so we have A4. So 1/2 of A is equals to 2. So what we're gonna do first is our A, like this, going to the right. Okay, we're gonna put linear 1, 2, 3, 4. And our 1/2 A is like this. So we're gonna put, so the equivalent of our 1/2 A is 2. Okay, so we're gonna count 1, 2, up and down, 1, 2. So basically it's your circle starts from here and end here at the 4. So your circle ends at the x-axis of 4. So basically from the center, gonna get up by 2 units and down by 2 units. Okay, from 1/2 A squared. A equals to 2. So basically after that, you can just connect this to make your circle. So that's how you get 4 cosine theta. So let's have another one. So we have here r equals to -6 cosine theta. So we're gonna draw here our lines, x-axis and y-axis. So if we remember here, if our A is negative, we're gonna move to the left. Okay, first we're gonna figure out our A. So our A is equals to -6. So 1/2 of A is equals to -3. So we're gonna start from here. We're gonna count 1, 2, 3, 4, 5, 6. And then our 1/2 A up, we count to 3. 1, 2, 3. And down, 1, 2, 3. So basically our center of our circle is this. 1/2 A is the -3. And the end is -6. So basically our center starts from here. And the 1/2 of our 6 is here. And here. And here. So basically you can draw our circle like this. So you gotta remember that this diameter of A is 6 is just equals to the diameter of a circle like this of A. So basically here, center of circle up is 1/2 of A. So basically 1/2 of A is just the radius. And when you're trying to find the area using the radius, we can have this formula. Area is equals to pi r squared. So r basically is negative 3. So we have pi -3 squared, which is just simply 9 pi. So now we're gonna discuss about polar coordinates. So how can we make our polar coordinates? So basically if we have here our -2 and 60 degrees, so basically this will be our r and this will be our theta. So here also 2 and 60, +2, -2, 60 degrees. So this is our r and this is our theta. So we're gonna draw here our line. So how do we do this? First we're gonna make our 1 radius 1 circle, radius 2 circle, and radius 3 circle. So basically our +2 will be going upward. So our 2, so just 1, 2, just here. So basically this will be our 90 degrees angle, 0 degree angle, 270 angle, and 180 degree angle. So basically this -2 is just -2 by 60 degrees is just 240 degrees. Why 240? Because just gonna add here 180 degrees. Okay, so this negative 2 is just going downwards, opposite side of the positive 2. So basically, this rotation from here is just 60 degrees. And from here to here is 240 degrees. So let's try another example here. We have negative 3 and 120 degrees, and 3 120 degrees. So we're gonna draw here our line, the sketch. So basically you have 3, okay, our radius 3 and our theta here. So we're gonna make 1 circle, 2 circle, and our 3. So this area is, remember, 90, 0, 270, and 180. So basically you have 120. So this our theta will be focusing here on this side. Positive, okay, first positive 3 here with 120 from here to here is 120 degrees, and our opposite angle of 3, sorry, just over here, R3, okay, from here or going around and here is 300, okay, for our negative 3, our opposite. So positive going upwards and negative going downwards. So 3 and negative 3 is the opposite of negative of positive 3 is just negative, so opposite side. So why the 300? We just add 120 by 180. So we have our 300 degrees. So basically this area here left is just only 60 degrees, negative 60 degrees. So all of this, let's apply this to finding the area in polar coordinates. So let's put our problem here. So first we're gonna find the area enclosed by one petal. Sorry for the cut. So by one petal of the polar curve. So here we have our r is equals to 2 cosine 30. Okay. So what we're gonna do is first we're gonna sketch this graph. Okay. So remember that this is our r and this is our theta. Okay. So the question is enclosed by one petal the polar curve. So our petal will be 3. Okay. 3 like this. This. Sorry for the petal. So and our r will be 2. So 1, 2 here. So what we're gonna find is the area enclosed by one petal. So this area only. So our formula for this will be area integral of alpha to beta 1/2 r squared d theta. So our problem for this is how do we find the angles, okay, of alpha and beta. So first we're gonna draw a line here and a line here. So to find this, we can use this, the number 3 in front of our theta, okay, to find those angles equivalent to our alpha and beta. So do you remember that this one is just 90 degrees? Okay. So we have here 90 degrees. So we can solve this by 90 degrees divided by 3 is just 30 degrees, or pi over 6. So our the equivalent of our two angles will be, this one is negative because it's at the downward, and at the top will be positive pi over 6. So now that we have our both angles, we can now substitute our r to the area formula. So a is equals to integral of negative pi 6 to positive pi over 6, 1/2 here, and our r is 2 cosine 3 theta d theta. So from here, I forgot the squared. Okay, so from here we can multiply this. So 2 multiplied by 2 is just 4. 4 multiplied by 1/2 is 2. So now we have our constant, so we can put our constant out. So here, let's put this here. So a is equals to 2 raised to 2 is just 4, multiplied by 1/2 is 2. So 2 here with the integral of negative pi over 6 to pi over 6, cosine squared 3 theta d theta. So basically, where do we put this? Our cosine squared theta is equals to 1/2 1 plus cosine 2 theta. But we have cosine 2 and 3 theta. So this will be just 1/2 plus cosine. So our theta is 2. So 3. We have 3 here. So our cosine 3 theta will be 3 times 2 is just 6. 6 theta. Okay, gets? Because our cosine theta is just equals to cosine 2 theta. And here we have 3 on the theta, so 3 times 2 theta, we have 6 theta. So now this will become 2 integral of negative pi 6 pi over 6 1/2 1 plus cosine 6 theta d theta. In here we can just cancel out 2 and 1/2, and what we'll get is here. Let's move it here. Area is just equals to integral of negative pi over 6 pi 6 1 plus cosine 6 theta d theta. And this just equals to theta plus, so the integral of cosine is just sine 6 theta over 6. And don't forget our limits of pi over 6 to pi to 6, negative pi over 6. So after this, we're gonna plug in our pi over 6 to our theta. So this will become pi over 6 plus pi over 6 multiplied by 6 is 0 over 6. So this will be just 0. Sorry, sine, so this will be 6 times pi over 6 is just pi, and sine of pi is 0. Okay, and then next we have here minus, so negative, we're gonna put next is our negative pi over 6, so it's just the same. Negative pi over 6 multiplied by 6 is just pi, so sine pi is just 0. So basically what we have here is pi over 6 plus pi over 6. This is not minus, this is plus. Okay, it just equals to 2 pi over 6, or simplify pi over 3, and this is our answer. In our volume, our next topic, we're gonna discuss the 3 method, disk, washer, and shell method. So first, I'm gonna just discuss to you the disk method. So first, I'm gonna make a graph here. So example, this is our graph. Okay, yeah, this curved line is y equals to x squared. So first, we're gonna review how we get our power of definite integral. So example, we have here integral of 0, limits of 0 to 2, integral of x squared dx. So what does this mean? So what we have here is we're gonna put here a limit of 0 and here are 2. So what we're gonna do is we're gonna multiply r dx by x squared. So what we're gonna have if we do this by power of definite integral, so we're gonna have our simple dx here, this one dx, and we're gonna multiply it by our limits of 0 to 2. So it's just the same. So but in this, we're not gonna find the area. Okay, we're gonna find the volume if we rotate this curve to x-axis, and what we're gonna have is like this. So if we also gonna rotate this dx, what we're gonna find is also like this, like this. Okay, so I'm gonna transfer this, it's just gonna look like this one. It will look like a coin. Okay, so how do we get this volume of this? So just the same cylinder, we're gonna find its area, and the formula for its area is just pi r squared. Okay, so if we know the radius of this area, we're gonna figure out the area of the whole coin or the whole disc. So what will be our radius here? So it's just the same in here, the height here. So what will be our height here is just f of x, or rx squared. So simply our r is just x squared. Okay, so simply this area is just equals to pi r, which is x squared. Okay, so simply our volume is just area multiplied by dx, which is pi x fourth. Okay, so by this we can solve this by applying our definite integral. So this will be just integral of limits to 2, 0 to 2, pi x fourth dx. So this one from the volume is just normal definite integer, so we can just solve this. So this is equal to, wait, let me focus. This is just equal to pi limits of 0 to 2 x4 dx. So by substituting, we can get this as pi open parenthesis rx4 by using power rule, rx4 plus 1, 4 plus 1. So simply this is just pi x to the 5th over 5th with limits of 0 to 2. Or simply, we can put this here as pi, we're gonna substitute our x by 2 raised to 5 over 5 minus same, we're gonna substitute our 0 raised to 5 or 5 or just 0. So this pi 32 over 5 minus 0 or just simply 32 pi over 5, and this will be our answer by using the disk method. So for the shell method, first we're gonna graph here. So our curved line will be like this one with A to B. So what we're gonna do is we're gonna put a rectangle here. Okay. So from this area up to this will be our R. Okay. And what we're gonna do here is we're gonna rotate this to Y axis, and this one over here is just our height. Okay, so by using shell method, we're gonna come up with our formula for the shell method. This will be volume is equal to 2 pi integral of a b, our radius x multiplied by height x dx. So basically, when using shell method, so when you want to get the volume of this, your radius and height must be in equal x axis. So when this is rotated in y axis, as I said, to get this volume, your r and height must be in x. Okay. So next, if you want to rotate your curve to y to x axis, so this will be like this. We're gonna put here DC, and our curve is just the same like this, and your rectangle is on the other side. Okay, so your height now is this. Okay, it's just the same like this, and now your radius is from here to here, and your formula is also the same, but y, but it's in y axis. Okay, so C to D, and your radius of y, height of y, dy. This is when you're rotating in y axis, and this one is when you're rotating on the x axis. So let's have our example here. Y is equals to square root of x, and y is equals to 0, and x is equals to 4 when rotating it to y axis. Okay, first we're gonna draw our line. our curve, I mean. And this is rotated to y-axis, okay? Much better if you're gonna graph this so you would understand it more. And we'll have here our x is equals to 4 and y is equals to 0. So we have our limits are 0 to 4. And we're gonna draw our curve here. It's just above 4, okay? So we're gonna, don't forget our rectangle here. So this will be our height. And from here to here will be our radius. Okay, then from here to here will be our x, because this will be our dx. And from here to here will be our y. So our r is equals to x and our h is equals to y, where from here our y is just square root of x, so our h will be square root of x. So by using the formula, v is equals to 2 pi integral of a to b r of x h of x dx. We can conclude this, we can substitute now our values. So wait, v is equals to 2 pi integral of 0 to 4 here, 0 to 4 x square root of x dx. So basically when you multiply our exponents, we're just gonna add their values. So our x is just here, we're gonna put this, our x is just x1 and our square root of x is x1 half. So 1 plus 1 half just equals to 2 over 2 plus 1 half, or just 3 over 2. Okay, so now we can substitute our 3 over 2 here. So we have let's continue over here. We have v is equals to 2 pi integral of 0 to 4 x3 over 2 dx. Okay, so basically this is just 2 pi x 5 over 2 multiply by 2 over 5 0 to 4. So y, this is 5 raised to 5 over 2. So the antiderivative of 3 over 2 is gonna add 1 here, so it's just x 5 over 2, and we're not gonna divide it by 5, let's just multiply it by 2 over 5. Okay, so by substituting our limits, we're gonna have here 2 pi 2 from here 2 pi, so 2 multiplied by 4 raised to 5 over 2 over 5 minus 2 times 0 5 over 2, or 5, or this will just be 0. Okay, so what is 4 5 raised to 5 over 2? So basically when you add the exponents of this, will be just for 1 half of 5. So 4 of 1 half is basically just square root of 4. So square root of 4 is 2 and raised to 5, which is equals to 32. So now we have here 2 pi 232, which is 4 over 52. 4 raised to 5 2, this is 5, so this is equals to 2 pi multiply this, we'll get 64 over 5, or simply just 128 pi 64 times 2. Okay, 120 pi over 5. Method. So basically this is just the opposite of this method. So first we have here, I'm gonna graph this x, y, and we have our curve just like this one and this one. So this will be our y, f of x is equals to square root of x, and this one is y equals to g of x equals to x. So basically we're gonna find the volume of this area, and we're gonna have our rectangle over here. And when we gonna rotate this, we're gonna have this like this. Okay, with limits of a to b. Okay, so the volume for the formula for this is just area is equals to pi f of x squared minus pi g of x squared. So area is just equal pi f of x squared minus g of x squared. So by applying the formula, we can get this as integral of a to b pi f of x squared minus g of x squared dx. So we can solve this using the formula. Okay, v is equals to the limit of 0 to 1 pi x minus x squared dx. So basically this is just pi integral of 0 to 1 x minus x squared dx is equals to pi x squared over 2 by using power rule, x3 over 3, limits of 0 to 1. Then this is just equal to pi 1/2 minus 1/3, and we're just gonna cross multiply this, and what we're gonna get is just simply pi over 6, and that's the answer by using washer method, the opposite of disk.